Let f of x equal x plus 2 divided by the quantity x minus 3, and g of x equal the square root of 4 minus x. Find f plus g, f minus g, f times g, and f divided by g, and find the domains of each. Now before we find these functions, let's recall how to find the domains of combined functions. Suppose f is a function with domain A and g is a function with domain B. Then the domain of f plus g, f minus g, and f times g will always be the same. And the domain is going to be the intersection of the two domains. F divided by g is a little bit different. The domain of f divided by g will be the intersection of A intersect B, such that g of x does not equal 0. Okay? Well, let's start by looking at part A. So let's find the function f plus g, and then we'll find the domain of f plus g. Well, f plus g is defined as f of x plus g of x, which is x plus 2 over x minus 3, there is f, plus g, square root of 4 minus x. Nothing to it. Now, to find the domain of f plus g, we must first find the domain of f, then we'll find the domain of g, and then we'll find where those two domains intersect. So let's take a look. The domain of f is all real numbers except 3. Now that's because f is a rational function. Rational functions are defined everywhere except for those values of x that make the denominator equal to 0. The only number making the denominator 0 is x equals 3. So all real numbers but 3. The domain of g, well, we can find that because we have a square root function. To find the domain of a square root function, we must set whatever under the radical greater than or equal to 0 and solve. So solving this inequality, we get x must be less than or equal to 4. So the domain of g is negative infinity to 4, inclusive on the 4. Now the domain of f plus g will be the intersection of these two domains. So let's see if we can figure that out. Notice that both domains extend indefinitely to the left, okay? But the second domain does not include, or excuse me, the first domain does not include 3, so we can't include it here. So we start at 3 and go to the left forever, okay? And then they intersect between 3 and 4. And we include the 4. So the intersection of the two domains, which is precisely the domain of f plus g, is negative infinity to 3, open parenthesis on the 3, union with 3 to 4, and we will include the 4. Now the nice thing about this is this will exactly be the domain of f minus g and f times g. Okay? So let's do f minus g. Okay? F minus g is f of x minus g of x, which is x plus 2 over x minus 3 minus the function g. So nothing to that again. Now the nice thing is we've already figured out the domain because it's exactly the same as the domain of f plus g, which we said was negative infinity to 3, union 3 to 4, and including the 4. All right, let's do part C. Fg is the same thing as f of x times g of x. So we get x plus 2 over x minus 3 times the square root of 4 minus x. And we could rewrite that as x plus 2 times the square root of 4 minus x, all divided by x minus 3. That might look a little nicer. Again, the domain's exactly the same as the first two. So we'll write negative infinity to 3, union with 3 to 4, and including the 4. And finally, we'll do part D. F over G is f of x divided by g of x. So we'll write x plus 2 over x minus 3. Divide that by our function g of x, which is the square root of 4 minus x. Now, if we want, we can clean that up a little bit. We could certainly write the square root of 4 minus x as the square root of 4 minus x over 1. And then we can invert and multiply, getting x plus 2 over the quantity x minus 3 times the square root of 4 minus x. Now, the domain is a little different. So let's stop and think here. What did we have at first? We had the intersection of the two domains was negative infinity to 3, union with 3 to 4. Okay, so the domain of f divided by g will be the a intersect b. However, we may have to pull out a point that make the denominator 0. Well, the denominator is 0 when x is 3, which we're not including. It'll also be 0 when x is 4. So we're going to have to pluck out the point of 4. Therefore, the domain of f over g is negative infinity to 3, union with 3 to 4, but non-inclusive on the 3 and non-inclusive on the 4.